Hello again, everyone. Hopefully you're able to hear me okay. I'll share my screen and we'll get started here in just one moment. All right, so we'll begin here today. Thanks everyone again for joining us. Here we are on the fourth and final stop here on our statistics webinar, ARM and statistics. Today we're focusing in on the analysis portion. The AOV Means Table report is our focus here. A couple of housekeeping items as we have on our other sessions. The chat is available here, and I just sent a message in that chat. That's the best place for questions. That way we can queue them up either as we're going along. If I do something a little too quick, you won't want to cover it again, we can do that. Or also at the end, we should have some time to cover any questions people have. Really good to have discussion. We've had great discussions thus far in the other sessions too. So feel free to put any questions you have in the chat. We are also recording this session as we have the others. So you'll be able to re-watch this or share it with others. Hopefully you're receiving the emails with those links. We also have them out on our website. So under our resources heading, we have a page devoted to webinars, and we post ones that are upcoming and then have our archives. And so here is the several sections. So I actually kind of changed the format just a little bit, and we'll put the link here. This is also my little reminder to myself. I wanted to bring up that we are planning more statistical themed webinars. So the response to this series was phenomenal. We had to turn off registration, and we're just kind of sending the recordings out to those who wouldn't fit into the meeting. We had a limit as to how many can join a meeting, and so we hit that and smashed that record and had more and more people connect. So we're hoping to try to continue these types of training as long as there is interest. And so we're kind of going one level deeper even, here with this series. We want it to be a beginner presentation. We're actually bringing in our statistician, Peter, to provide some more advanced statistic training in this case. We don't quite have dates set. We're hoping sometime next month. Maybe later in the month is what it's looking like, but we have to get our calendar synced here. But the focus will be on hierarchical designs, really looking at the multi-factor, whether it's a factorial or split plot design. And then the second session will be repeated measures, kind of a compare and contrast of doing a repeated measures analysis versus split plot designs. So we're just kind of finalizing the dates and get the registration up and going for that. We'll probably also send an email out to everyone who's registered for these sessions here in case you're interested or want to forward it on to someone in your group who is interested. So be looking for that. My one other housekeeping item is just a little clarification on a little bit of discussion from yesterday. So if you were with us in yesterday's session, there was a question about ST. So we were working in the data correction section about how we can apply these transformations, and ARM has automatic transformations. So the raw data stays the same, but you have this code that then when you run the analysis, the transformation is applied and then the analysis done on that transformation. The question then was about our summary across trials add-in, where we are combining multiple trials. And I think my response might have just been a little bit confusing and potentially misleading. I had a couple of questions afterwards on that. So I just kind of wanted to clarify that those automatic action codes that are in a single trial that we were working with on the single trial analysis, those are very important for the single trial analysis, but they are less important in the multi-summary or multi-trial summary because we're combining those trials. So you really don't have that same issue with homogeneity variance or things like that. And so ST does not take an action on those automatic action codes. So if you're putting them in this one trial that you're looking at to get the single trial summary, that's great and perfect. But the ST summary, that's not going to affect or mess up your multi-trial analysis in ST. So really what you see in the assessment editor, your raw data that you've entered, that's what ST is going to use. It's going to take that data, combine it with any of the other trials, and use that together. Really, my answer was trying to reflect the idea that you probably want to be consistent in how you apply some of these transformations in the certain types of assessments that lend themselves to needing some of those. So if you're doing disease counts or insect counts where it's going to be a very rare occurrence, that was an example of like a Poisson distribution is typically how the data ends up. And so you typically need one of those calculations. Before the fact, you might want to say all of our trials for that assessment, that's the one we're going to want to put on before we even see the data. So there is a benefit to doing that in your protocol or as you're planning out that study to do them in all of the trials. But I think that point just got a little washed into talking about what ST actually does. So kind of two different steps. ST isn't so worried about those transformations, but there is a benefit to doing it consistently. So that way all of your different single trial analysis, you're doing that all consistently as a group. So hopefully that helps a little bit clarify. And if you did have any questions or in ST see something that you're not quite certain about, feel free to send us an email and we can kind of help through that too. So, all right, with that then, we'll dive into today's subject, which is the kind of last step on this statistical process, the analysis. Really looking at the reporting. And so here I just have our PowerPoint slide that we had went through all in our first session. We had walked through the analysis of variance and showed the AOV table and kind of how those numbers get calculated. And so just wanted to real quick summarize what that was. Really your AOV or that ANOVA analysis breaks apart the variance in your data into different sources. And then we get a p-value, really a probability in the end, giving us kind of a percent confidence that no differences exist among those treatment means that we were looking at. And so in our data that we had done, our p-value was 0.04. Really, then we can say we are 96% sure that there is a difference in treatment means. But the real trick, and I think a little bit of confusion when you see the final report, is that's step one of two. You really then run a mean comparison test to figure out which differences there are. So really, when we see the report in ARM, there's the ANOVA analysis that was done, and then there's a second step, which is running the mean comparison test. And we had talked about the different options for them. How do I choose? We discussed that kind of in the first day of which one you would want to do, and then we showed an example of kind of how those letters are calculated. So I will switch over here then to a trial. It's just kind of an example trial here that has a couple of examples just to really show how we do this in ARM. And so if you haven't done much reporting in ARM before, we're going to use the print reports tool to run this analysis. And so that is found under the File menu in Print Reports. And it always displays weird when I've changed my screen resolution here. So let me recenter. And so now we're on the Print Reports dialog. And here on the available reports to the left is really essentially a menu of different components and reports that you can generate. And we will select the AOV Means Table is the main option that you want. When you select that here, you just press the Add button to put it into your list here of the reports you want to include in your printout. And you can include multiple components, and those will just be put all together in a single output if you haven't used that before. So this AOV Means Table, there are a lot of options to kind of customize the analysis that you're going to do. And so we'll kind of talk about the most common ones, a lot of the common questions that we see. I just kind of want to start by previewing this report. So there's a tab here, and this will just kind of give us a nice overview of what the report looks like. It prints just the first 5 data columns, just to give an idea of what we'll get. You can always press the next to have it generate across all of the data columns, but this will work for today. So this first section here on the page is just the header. So that's the header section from your trial, gets put on all of the reports. So this is really the main content of our AOV report. And so starting in the middle here, we have our treatment list. So we have 5 different treatment products. We can customize how many, what pieces of information from the treatments editor gets put here. Kind of the bare minimum. We do have this tub product applied at 2 different rates, so we want a bare minimum to include those 2. And then to the right, we have each of those assessment data columns. So those correspond to each of our assessments that were performed. And we have treatment means. So here we are summarizing across all of our replicates to get treatment means for each of those assessments. Right next to that are the mean comparison letters, the results of that mean comparison test that gets run. Up above here is that description of the assessment. So that's that assessment data header section in the editor that describes the assessment. Underneath then are some descriptive statistics corresponding to the analysis that was run. And then we have the kind of the AOV analysis here. Those are those F ratios that we talked about calculating, and then the p-value from those F ratios, both for the replicate and the treatment source from that AOV table that we had saw in our first day. So that's the main structure of the report, and that's really, you're looking at that analysis to see the treatment means, and you're looking for mean separation. So looking at like data column 2 here, we talked about how if you have a different letter, 2 means, if we were to compare treatment 1 to treatment 2, if they have the same letter, then they are not significantly different. If they do not have a letter in common, then that means there is a significant difference between the 2. And so we have an A, and the rest of these are B, which means treatment 1 is different from every other treatment in this list. There's no more A's. But then looking at treatments 2 through 5, there are no significant differences between them. They all have that B letter in common. So kind of diving into some of the common questions that we hear, and we'll kind of show the question and then where you can fix that, or what option is controlling what you're seeing there in the report. First one here, if you're looking at data column 1, a lot of times there's a question of, well, where are my letters? I don't even see any letters here. In this case, there's just a dash. So what does that mean? And so that means that there were no significant differences found And if you go to your AOV report options, there's an option here right at the beginning, the symbol indicating no significant difference between treatment means. Essentially, you can customize whatever you would want ARM to put in place of the mean comparison test to signify that there was no differences. So a dash is there by default. You could do something like NS. If I preview the report again, you'll see that instead of those dashes, now you have NS for no significance, whatever kind of denotation you would want. Another common one would just be the letter A, because then you have all A's all the way down, so it still looks, you know, like the same similar output for mean comparison, and the result just is they all are the same letter, and so they all are not different. So that choice is yours on how you would want to denote that, but by default, there's that dash, and so that sometimes causes a little bit of confusion. There is a kind of the same question, just kind of depends on the situation, that very same question of where are my letters, where maybe you have all A's or all of those dashes, but you were expecting a difference. And I have that here in a sample report. I just had one from a support question a long time ago here. That was just a handy example here. So this column number 2, we had the treatment means here, and the LSD value here was 9.54. And we kind of talked about that, a mean comparison test, that LSD is the value that's used to compare 2 different treatment means. And if the difference between your treatment means is larger than this LSD value, then the LSD mean comparison test would call those significantly different. So that's a common question. Is I'm looking at this report here, for example, column 2, my LSD is 9.54. Clearly column 6, or excuse me, treatment 6 should be significantly different from treatment 1. There's a difference of almost 14, far exceeding the LSD value. So how come I don't have any significance being displayed on the report? So there's really kind of 2 possibilities here. The one in this report is actually the mean separation test that's being run. In this example is the SNK, the student Newman-Kules. So the student Newman-Kules is a little more conservative, as we had said before, so it's a little less likely to separate treatment means compared to the LSD. So although the LSD, if we had run the LSD mean separation test, there would be differences. The SNK did not detect those differences. So that's just one thing to check. This was a standardized summary, which isn't used very often. You would more often see that denotation of what mean separation is run here in this first line in the, let me zoom in a little bit. I bet that's a little small here. First footnote where it says means followed by the same letter or symbol do not significantly differ. And it has your significance level that we ran the test on, and then the test itself, student Newman-Kules. So that's where you can confirm that, no, we didn't use the LSD mean separation test to get those letters. We used the SNK instead. So utilizing that LSD value, it's really only good to investigate one particular pair, and that might not match up with the mean separation letters on that report if the report itself didn't use the LSD. So that would be one thing to check when you see no significance being noted, even though maybe that LSD could suggest that, because you might just be running a more conservative test. The other option, so if I go to my report options and let's change it to LSD, and preview the report, you'll see that we actually still have that very same problem here in column 1, even though we're running the LSD. The other thing to look for is the treatment probability of F. So this number, which if you recall when we had split up all that variance, that was really that p-value at the end of the ANOVA that really tells us, is there any significant differences or not? So the ANOVA only really checks if there are any differences, not specifically which ones. And so in this case, that p-value is 0.6. So we would only be 40% confident that there is any differences at all in these treatments for this assessment, which is far worse than our significance level of 5%, which the significance level really says if we can't be more confident than 5%, then we really can't say anything at all. So really the ANOVA analysis is saying, I can't detect any differences. So then really is it logical then to still proceed to run a mean separation test? And that is what's known as a protected test. So if you go to your report options, it's actually right above the last option we looked at, only when significant AOV treatment P of F. So when this option is on, then ARM will not run the mean separation test for a data column that the treatment P of F or the ANOVA result indicates there are no differences. And so that's considered a protected test, and is generally the kind of the statistically recommended thing to do. If you did not want to do that, if you wanted to just say, well, even if the ANOVA doesn't think there's differences, let's just go ahead and see what we get. You do have the option to turn that off and then look at the report, and it will run that mean separation. And here we still didn't even get one in this case. Yeah, the LSD value is still too large, but that's kind of the other possibility when you're looking at your report and you don't have differences, even though you would expect that they would. You would really want to look first at the mean separation test that was used, and then second, look at your treatment probability of F. And if that's too large, it may not be wise to run a mean separation test, given that the ANOVA analysis didn't find any reason to think that there were differences. So I'll turn that back on. So that's far and away the #1 question we get in our support, especially reporting season, is where are my letters? Why am I not seeing that? And those are really the 2 or 3 big things to look for when you're faced with that situation. Another common question here, if we look at data column 5, you'll notice that one of these treatments actually doesn't have a letter. So how come I don't have a letter next to this one? Is it so different from everything else, or why don't I have something there with that treatment? And the reason that is blank is due to the ARM action codes field here. So if we look for this as data column number 5, we have ET1 is an action code that has been applied. And so that is excluding treatment number 1 from the analysis. So we still will print the treatment mean on the report for reference, but we've decided to leave that entire treatment out of the analysis itself. And here in this case, it might not be a huge surprise that would be left out. That untreated check is so much larger than these other treatments, and we really want to zero in on the differences between those treatments and not the check treatment. So that might have been why we made that choice. The idea of excluding the treatment was an option in the data correction workflow. We had worked on yesterday with the what to do if you didn't meet the assumptions of AOV. The old system in ARM, that was on the table. So if you didn't have any data corrections that would work, we checked to see if any treatments could be tossed out as well. And so that might be one other reason why that could get introduced, but really not ideal, of course, to throw out an entire treatment just for the sake of running an analysis. But there might be cases like in that untreated check where you really don't need that value in there. And so that ET1, if I look on my column 5, there are a couple of other action codes that do similar items here. So they're all in this section here that are non-analyzable data is really what these codes will do. And so the first one here, EC, will automatically exclude your check treatment. So in your trial settings, you tell ARM which treatment numbers are your untreated checks. And so then if you put the EC code in there, ARM will automatically exclude those treatments from the analysis. Or there's the ETN, and we just put N in there because you would put the actual number of the treatment you would want to toss out. Or ER will drop out a replicate. And again, the nice thing with this option here is it's doing it specific to this data column. So only when we're analyzing data column number 5 are we throwing out treatment number 1, or would we throw out the check or the second replicate. ES will exclude that entire data column from all summary reports. So it pretty much hides it entirely from a report. EST does something similar with the summary across trials. So if you want to hide that data column so it's never included in any ST summary, put EST in that action code. N will drop out the statistical portion of that column, so don't run any statistics at all. And on the report, it will just put the data from the first replicate as your treatment, for each treatment. So that would be a case where maybe if you're taking an assessment where you don't have, you're only looking at in one replicate, or you only have the first replicate of data, then you would, of course, not have anything to analyze. Using the N action code, at least will report those initial values without doing any stats. NM will still display treatment means, but it just won't run any analysis. So these are kind of ways to customize on a per column basis what to do with the data when we go to analyze in the report. Thinking about tossing out a treatment or maybe a replicate if an entire replicate got messed up, things like that. There is also an option, instead of going column by column, you can do that across the whole report. So those are in the report options. So I'll go back to print reports. And I'll have to do this probably every time we open that. So for the treatment, if we wanted to exclude an entire treatment from the whole report, you click on Global Report Settings here in the middle. The first option here on the General tab is for treatments, and typically you have Print All is selected, but if you choose Print Selected, then ARM will ask you which treatments to include in the report. So you could leave out the one treatment that you don't want to include in the analysis. Similarly for replicates, this would be under the general summary reports. So if you choose that option here, down at the bottom, there's an option to print selected replicates. So now we can choose which replicates to include, and we'll drop out the ones that we don't. So if I go ahead and say next, we'll see what happens there. So because we did the print selected for treatments, now we can hand choose which treatment numbers we want, whether you click on the editor to choose them, or you could just type in the range here as well. So here I'm going to choose 2 through 5 to totally leave out that untreated check from all of the data columns in the report. And now here we can choose which assessment column numbers to include. So I guess I didn't show that option specifically, but I must have had it on. So here again, you can click into data column, whether it's the heading or the data, to choose which columns to include. And if we want to leave out number 5 for whatever reason, you can just hand choose or type in your range. And then this is replicate numbers. So again, we can choose replicate 1, 2, and 3 and leave out number 4. Then we have just our kind of summary messages here. And if I just preview this report on the screen, again, this runs now all of the data columns, at least that we chose. So we can see we have 1, 2, 3, 4, 6, and 7. So column 5 is missing. We also have treatment 1 is gone. So it starts with 2 because we dropped that one out. A little harder to see that we have missing, we dropped out a replicate, but there is a footnote here that we excluded replicate number 4 in all of the columns. If I close that, and I'm just going to go previous to get back to the options here. That's how you can kind of customize the pieces. Again, whether you use the ARM action codes field is the way to choose those per column, or you can use the report options to customize that across the whole report. I'm actually just going to turn these back on to do print all the data columns. So we had that selected already, but under the general summary, you can choose whether you want to include all of the assessment data columns. Select, of course, allows you to choose which ones. And in that selection, you can change the order as well. So if I were to choose 5, 4, 3, 2, 1, when I selected them, then that's the order they'll be on the report. So that's a nice way to manually apply some sort of different order you would want those columns to be in. And same thing goes for the treatment selection. If we wanted those treatments to be in a different order, it's the very same thing. You turn on the select option, you can still select them all, but the order that you choose them in then becomes the order on the report. Automatic will, in this case for the data columns, just include any data column that has data in it on the report. And then let me turn off that print selected replicates. One more thing I want to show that is specific to the analysis, kind of tying right back to the mean comparison tests. That question of, well, how come I don't see any differences if I'm expecting a difference? And we showed some of the options that may or may not be on, but one other thing you can look at is, well, why aren't I seeing any significance? Why is my LSD value so small? I can't see any, or large enough. It's not small enough to actually get differences to pop up compared to my treatments. And so if you go to the AOV options, and it's the very last option in the descriptive statistics called Post-hoc power analysis. This turns on a couple of different features within your report. So what it does here is we have a couple of new statistics here in our table. There's the largest mean difference, so that's 0.93. So that looks at your list of treatment means and what was the largest difference. You know, basically find the lowest treatment and the highest treatment and what's that difference. And that was 0.93. And that's really 7% of the grand mean. Now you compare that to what your LSD value was, which is 1.46, and we realize that the LSD value was too large. So we weren't going, the LSD test is not going to find any differences because the largest difference that existed was only 0.93, and we needed at least 1.46 before we could declare two treatment means to be different. And that corresponds to 13% of the grand mean. So that shows that doesn't matter what mean comparison test we ran, you know, LSD is the most liberal that would find it if it was there, type of thing, wasn't going to happen here. And so then we get another row here for the minimum replicates. And so this will tell you that given your chosen statistical parameters, we had that alpha level of 5% significance, and given our AOV analysis here, we would have needed 17 replicates in order to significantly, to find a significant difference of that 0.93. So this is a nice planning tool for next year. Obviously, we can't just make 17 replicates appear for this trial and have enough data to see those differences, but it can be a great tool for looking at next year of what to plan for. And maybe the 17 replicates that can be across different trial sites. So maybe this individual trial, we're not seeing that significant difference, but if we ran 5 other trials, so here we had 4 replicates. If we ran 5 trials in total that all had 4 replicates, well, now if they all had similar results, you're going to have more than 17 replicates when you combine all of them. And so you may actually have a chance at seeing significant differences once you combine them all. So I think that's something that sometimes if you're in a CRO type of situation where your research is being contracted out, you're not necessarily required to have significance at your single trial site in the results. That may not be what the sponsor is really looking for. They'll combine your trial with many other trials to be able to find a significant difference in all of that data. Instead, the goal for you is to perform that research as best as you can to make sure your values, those assessments are accurate and such. But to in the end not have significance in that situation doesn't mean you failed in any way, shape, or form. So that's one thing I think we see in some of the support questions that people really stress out about not having those letters. Depending on your role, depending on that research, that might not be the end all. And so you'll note this is done on all of the data columns. So, looking at data column 2, we actually only would have needed 2 replicates to separate those differences, which isn't too surprising since there's such a glaring difference. The worst one here is 3.88 compared to 15. So there's a very obvious difference between the untreated check and the rest of those treatments. So it's not too surprising you wouldn't need a lot of replicates. But really that calculation, this is kind of a post-hoc analysis. It's really kind of an after the fact, well, what happened, what could have we done? And that's very similar to the calculation that's done. If I go into settings, and then on the design tab, if you've ever seen this power and efficiency tool, it's really the same statistical calculation. It's just really kind of the after the fact you have what actually transpired to run through that result. Whereas here on this design tab, they're a little more theoretical. So you would want to use this tool when you're planning your protocol for the next year. What is a typical CV you would expect? And, you know, the power, the significance level that you run, and that percent mean difference, just like we saw in the report. You know, how big of a difference are you going to try to detect? And this will tell you then, well, if you achieve a CV of 10, you're going to need those 17 replicates for a 5 treatment study. So that's kind of how you use that. It is the exact same statistical formula that we're using with that post-hoc. It's just kind of a before and after type of look there. And so again, just to show where that was, the after the fact, the post-hoc, that is in the AOV report options at the very bottom here, the post-hoc power analysis. So that's a really good tool for kind of planning next year's if you're building onto this, or to just kind of debug a little bit of how come I'm not seeing differences as well, to kind of see some of the statistical parameters that go into that too. Oops. So one more example, and we've talked about it a little bit, but it's probably the second most popular question I think we get on the AOV report is with the transformations. So those automatic transformations that you have. So if we look at data column 4 here, you'll note that we do have one of those automatic transformations that we had talked about yesterday. This is the automatic log transformation. And so as we kind of described yesterday, what really happens behind the scenes here in this column is that the raw data that we've entered over here, those values all get transformed, in this case with the log transformation. And then those calculated values, that's actually what we use to run the ANOVA analysis and run the mean comparisons. And so the result then would be you'll have all of these values, kind of the log of those values would be what's used in the analysis. And so that's what we could report and have the mean comparison numbers next to them. The only trouble is that's not particularly easy to comprehend. So, you know, here we have a percent area, but it's pretty hard to imagine what is the log of the percent area. You know, what does that number mean? And so what we can do on the report is we de-transform those treatment means back into the original units. And so we do that with this option under the general summary, de-transform means. So essentially, we still have all of the analysis done in the data corrected numbers, but just to report those means aren't going to really do us a lot of good. It's hard to imagine that, envision that. It's hard to compare with other trials as well. So then we instead kind of do the inverse transformation to get those means back into the original units, so we can kind of compare and think about them in the real world, if you will. So you'll notice here we've got 2, 21, 28, 27, 11. If I do turn this option off, oops, that's the general summary section. Now you'll notice that these numbers, these treatment means are drastically different. And so this really is those transformed values. So this is really where we've had the analysis being performed on is the log values. But again, that doesn't have kind of a real world meaning to it if you were to look at those numbers. And so that's kind of why that a de-transform means option exists. It also kind of clears up, you know, percent area. This really isn't 0.5%. This is not 1.48%. So it can kind of help with some of that as well. Because these are transformed with that log transformation. And all of these statistics in either case the analysis itself and the results are all done in that realm, in that transformed data, because that's what we wanted to do. But when we turn this option on, now those values are de-transformed back to kind of our original units. Couple of hang-ups, couple of spots where this does really impact people and where we get questions. Number one, you'll notice that the LSD, suddenly we have 2 values here, and it's actually a whole range of values. So that one can be a little bit confusing. Why don't I have just 1 value? And we do have a write-up on that. I can't just rattle it off the top of my head, to be honest. So I typically bring up the help topic here and just say, well, look up the LSD range. I usually just search on that, and there we have a topic that will describe in its gory math details exactly what happens. But essentially, and we kind of walk through exactly how that range is calculated, and how you would make comparisons with that value. But really, it's because we're working with those weighted means. If you're comparing the smallest 2 transformed means versus the 2 most extreme treatment means, you're really using a different value, when you de-transform those. And so that kind of throws it for a loop. It's a little bit of a tricky situation, but mathematically, that's what you have to do. That these comparisons here really aren't being used. Each pairwise comparison really doesn't have just that 1 true LSD value to it because of that de-transformation. So that's one caveat, one trick to that. You'll see that range, and that's why. The other big question then from this de-transformation is that if you were to look at the raw treatment means, they won't necessarily line up with the means here. And actually, if we wanted to do that, I could duplicate that column. Maybe I will in a moment here. But really, the raw means don't necessarily line up directly with these means. And that's because these are really weighted means. Because we transformed them with the log transform, took the raw data, transformed them, and then calculated the mean of those treatments. Then we do the inverse transformation back, and so you don't end up with the arithmetic mean in the first place again. It's a weighted mean. I'm a math major, so in my head, I rationalize it at the order of operations is different. It's like the log transform or the square root. It's really the square root of your data value plus 0.5, I think, is the actual transformation that's being done. So depending on what order you do that, you don't get back to the same place. Is how I rationalize it in my head, at least, of why that is the case. So sometimes people, it kind of bothers some people that they really want the raw arithmetic mean. And so kind of the workaround for that, what you can do if you really want that raw mean on the report, is this is typically the process that I would recommend. Really what I would do is I would insert a new data column. So here we're looking at data column 4. I'm going to right click, insert a new data column right at 5. So it can be just kind of right after this point. And I'm going to take off my automatic logarithm transform. So take off the AL. And instead, I want to transform data column 4. So I'll do this log transformation and store that in data column 5. So instead of having ARM do that automatic process within the same data column, I'm just going to give myself, let's do 2 decimal accuracy here. I'm going to put that transformation in its own column. Then I'm going to use this NM action code that we talked about before to basically tell ARM, I don't want you to analyze this data because we've determined in our data review that we can't do the AOV on the raw data. So using NM, I'll turn off that analysis, and then we'll get the true analysis here just in column number 5. So now in our preview here, column number 4 with our raw data, we can see our arithmetic means that we wanted. And now in column number 5 is the same data, but really our, our analysis. So the transform data, if you want, this is kind of a nice way to see how the raw arithmetic means don't line up directly with the D-transformed means. If it's even easier, maybe in this case, you'd maybe turn off the D-transformed means. So it's very clear to the reader that this analysis is all done on that transformed data. That would be my recommendation. That's typically how we steer people who have that question and are really concerned about seeing the arithmetic means on their report. It is a little bit messier in the regards of you're inserting a data column, and it is a popular a common request. So there may be a new option in the future, or something that we can provide a little more fine-tuned options for people, but that's really kind of how we're recommending approaching that problem right now, at least. So those are the big hitters. I guess I kind of want to leave a little time for questions. I have a couple of other little features that I could show, but I wouldn't want to soak up all of the time if there are some questions. So I definitely kind of want to leave the door open here if people have some questions on what we showed, or some other questions kind of related to the topics we've discussed. Please feel free to fill those in the chat, and we can cover any of those questions. That was kind of part of the goal here, was to show the common ones. I think some of it is just kind of wondering what other people ask, and really everything that we've shown today, we get at least twice a week over the course of 2 months of that common reporting time, in some varying question or another. On occasion, it's kind of specific to their data. You can send us your trial and report set, and we can see what you're seeing on our computer and kind of help you through what you would need to look at as well. If it's kind of data specific, we can do that. But I guess if there aren't any huge questions here, I'll show just a couple of little quick hitters, some time savers. One of them actually was one I just actually did here. I've got this off my screen again. That number of decimals. That's a question we get sometimes, especially with these transformations. So if I had left that blank, you get a whole lot of decimal places, and it can be very unnecessary on the report. So if you ever see this, that usually happens with some of the transformations where you just have a lot of digits that you definitely don't need. There's kind of two ways to do that. If you want to specifically pinpoint just this data column, how many digits do I want, then you use this number of decimals row in your header. And if you don't see that field, just make sure to use in your properties, there's this hidden field section. So I think number of decimals is actually the very last one in the view, and you can just turn it on here if you don't see it immediately. But that chooses kind of how many. Maybe I'll choose 4 for here just to show the difference. That'll change how you see it on the editor, but also in the report, how many decimals are used there. If you wanted to choose across the whole entire report how many decimals you see, that you can do in the general summary. There's an option to force the number of decimals accuracy. So maybe I want to override anything I've chosen, and just on this report, I only need 1 decimal point. And now you can see for all of the data columns, we have that. I think, let me go next and actually generate that report. It seems like it's not showing up on the preview. See if it does here once I've actually kind of fully generated that. No. Oh, so I think that number of decimals field overrides that option. Sorry about that. So if I were to clear out these choices here that I already had made, if I hadn't utilized that field myself, then that option, again, it was the general summary, force number of decimals, accuracy, then that takes, puts that into place here on your report. And if you want to save space on your report, you know, there's a lot of assessment header fields that are used a lot of times. So like your pest and your crop, you know, those each take up like 4 different rows, and that can be a little much. So if I were to show like all fields here, then in the report, again, in that general summary section, you can choose what header rows get included. And so automatic will include any row that has content in it will get included on the report. Problem is, if I zoom out, you'll see that doesn't leave a whole lot of space for anything else on this page. So I'm actually getting cut off, and I have to wait till the next page to get my statistics here. And so that makes quite a mess on the report. You'll use way more pages than you would really need if you have too much space on that page taken up by those header fields. So if you choose something like select, then when you go to generate that report, you can choose which rows get included. So maybe I only need my codes for each of those, and then my rating date and the description. This is a chance to also change the order again. So if I want my number of subsamples before my sample size, I can do that. I'll make sure to include the action code. Now, when I preview the report, it's so much smaller now. You can fit everything on a page. Question here, kind of about how those pages break out. So the question being if you can choose the page breaks in the reporting. And so by default, ARM will start a new page for each kind of report component that you choose. So if I go previous, and in addition to my AOV means table, maybe I want to first have a trial treatments. I first would like to print out the treatments. So if I hold shift and press the up arrow, I can put that first in my list. And then I want to see maybe my spray seeding plan. We'll put that second. Then the AOV means table, and then my trial map. Just pick kind of a random selection. By default, ARM will start on a new page after each of these components. And there's just some additional prompting. That was for the spray seeding plan, choosing the header line numbers. So now if we preview, first page is trial treatments. And although there's plenty of space here on this page, it starts on the next section with the spray seeding plan report. And then similarly, this one actually has several sections for each application code. So that actually spans 4 pages. And then it starts a new page for the AOV. So that's automatic. So the question kind of is, if I can choose the page breaks, you can't necessarily select when that page break happens. It will happen when the next report starts. If you wanted to squish the reports a little bit, you can use this remove page break option. And so now if there's at least 10% empty space on that page, it'll actually bring that next report and start on that same page. And so here we have the trial treatments section, and then it immediately starts in with the next report. So here that spray seeding plan gets put on here because there's enough space. It looks like actually I have my margins kind of set a little strange. So this might, that'll make it look a little more normal. So that immediately starts up on the next page. That does sometimes cause some goofiness, but yeah, that would be the first thing to check, is that remove page break option. It's nice in some cases to have that on, and then in others, like in this case here, it kind of makes this page look weird because it's just starting as soon as the spray seeding plan is done. Well, let's put the AOV report. Well, then that has to get put on this other page to line up, and it just looks a little weird. So sometimes it doesn't quite work out as well as we'd like on that option. But that's the remove page break option. Yeah, so if your report looks really squished, chances are this is on, and you'd actually want to turn that off to get to see those page breaks. All right, great question. Well, it's the top of the hour. I've gotten through kind of everything we wanted to cover today. If you're working on typing a question or something, we can certainly hang around for a few more minutes. But I want to thank everyone who could attend today and throughout these sessions. It's been really great to have such interest in these topics. And we look forward to doing maybe more statistical oriented webinars in the future based on the feedback. I'll send another email with the recording when we're all done, and just be looking for other webinars in the future. We'll post them on our website, and probably also maybe send an email out when we have dates for sure on that advanced ST training. So thanks everyone for joining. Looks like I do have one more question here we can cover for those who have time, and it's displaying the comments in the report. So I want to check here on the comments if we're talking about the comments section in ARM. You mentioned that you had signs of erosion. I can't type, but that's okay. So something like that. Lisa, is this the spot there that you would be entering that? If that's the case, there is in the print reports. And again, I knew that was going to get annoying. I have to change that because of my display settings here. But there is in your report list a trial comments component. So if I add that to my list here, actually we can just preview it on the screen. That will put any of those comments that you've entered in that comments editor. That'll put that right in your reporting. And I think there's an option here to keep with previous page, so that it'll actually ignore that page break option that we had used before. If you were thinking more about the comments specific in the assessment data, so we had talked about in the data review, where if you were marking this as damaged, or you just had some comment that you entered, if you're looking for that information, you can include that in the assessment data summary report. So that is the assessment data summary. You can include that comment, you can include the barcode GPS, things like that. And really this report just generates the raw data that you've entered. Really the only analysis is there is a treatment mean, but there you can see the comment. Maybe I'll zoom in just a little bit for that plot 101 that we entered can get put into the report there. So those would be kind of your two options, depending on where that comment information is stored. All right. Well, thanks everyone again for the good questions and conversations, and I'll send out that recording as soon as we get it uploaded. So thanks everyone.